Well, hello. Welcome to another exciting episode of Fun with Physics. This is your host, Mr. Easley. We are looking at physics classroom, specifically electric circuits or electric current 9. Now, this first question on here is that I have is actually, let me back out a little bit here. There we go. Maybe a little hard to read, but what it basically says is two non-identical lights, they're not the same A and B, are connected in series with a 38 volt energy source. So let's go ahead and mark that down. So this would be 38 volts. It's important to start marking things and thinking about what's going on. So what that's saying is from here to here, remember this is going up by 38 volts. Then it says the voltage drop across light bulb A is 16 volts. So we can show this, 16 volts. It says, what is the voltage drop across light B? So it's wanting to know, what is the drop across here? Okay, so the way this is very commonly written is you can kind of think of the battery as V1, and then each of these batteries as, each of these lights, this might be V2, and we could call this one V3. And to put this into an equation, you could say, and this is what the loop rule tells us, is V1 equals V2 plus V3. And so basically we can see that V1 is 38. It's going to equal 16 plus V3. And I'm not going to go too much into detail other than to just tell you that we then know that if we subtract 16 from both sides, we get 22 is equal to V3. So in fact, this drop would be 22 volts. This next question is essentially asking the same thing as we did before. The only thing you need to make the transfer is to realize that there's many things can be a resistor. You can do a light. The voltage drop can be across anything really. So here it shows a light bulb and then a speaker. But in this case, it's important to remember that the voltage drop is kind of regardless of whatever the device is. It still has to do with its resistance, and it still is subtracted away. If we move on further down in the assignment, it does get a little more involved. Excuse me. I was trying to pause it, but I didn't get there in time. Here, it sets up a scenario, and I'm going to pause it. All right, so I went ahead and drew that up, and it tells us that we have an 11.6 volt battery, and then we have two resistors, resistor A and resistor B. And it also tells us that resistor A has twice the resistance of resistor B. Now, the way that we would work this out is we're going to need to do a couple of things. One, we're going to need to bear in mind, and we could go ahead and label this as, you could think of it as V1, V2, and V3 for our three areas of voltage. And we can remember that V1 is going to equal V2 plus V3. We are definitely going to do that. We also know, they just told us that resistor A has twice the resistance of resistor B. So we can say that